Have you ever stopped and wondered what the world is actually written in? Not English or Spanish, but the real, fundamental language of matter itself? Well, today we're going to decode that alphabet, the tiny building blocks that write the story of, well, everything.
It's honestly one of the biggest questions you can ask, right? And the answer is kind of wild. It's both incredibly simple and amazingly complex all at once. To get it, we have to zoom way, way in, down to the smallest possible piece of anything. All right, so let's start at the very beginning, with the most basic component there is, the atom. The easiest way to think about it, it's like the single individual brick that you use to build the entire universe. So here's the key idea. If you took a chunk of pure iron and you just kept cutting it in half, over and over again, eventually you'd get to a piece so small you couldn't cut it anymore and still have it be iron. That tiny little bit, that's a single iron atom. It's the fundamental unit. And here they are. This is the master list of every single type of brick we know of. It's the periodic table of elements, and you can think of it as the ultimate catalog for all of chemistry. Pretty cool, right? To make this even easier, let's stick with an analogy. Think of all these atoms as just individual letters in a giant cosmic alphabet. You've got the letter Mg for magnesium or Fe for iron. Each one is a totally unique character. But, just having a bunch of letters isn't that exciting. The real magic, the part where things get interesting, is when these atoms start linking up. This is how we go from just letters to making actual words. To really see this in action, let's picture a classic chemistry experiment. What do you think happens when you drop a piece of metal, say magnesium, into some acid? It doesn't just vanish. No, something way cooler happens. The atoms completely rearrange themselves. This is exactly what that reaction looks like on paper. You have a single atom of magnesium, and it reacts with hydrochloric acid. And in that moment, old bonds between atoms break and brand new ones form. You end up with completely new stuff on the other side. And how do we know for sure that something new was made? Well, you can literally see it. The fizzing, those bubbles, that's your physical proof that a chemical reaction is happening. A brand new substance, in this case hydrogen gas, is being created right there in front of you. And this brings us to the next big idea. That gas that's bubbling up, it's not made of single, lonely hydrogen atoms, or H. No, it's made of two hydrogen atoms bonded together. We call that H2, or a hydrogen molecule. It's just like taking the letter H and writing it twice to make a little word. So that's what a molecule is. It's simply a team of atoms. Sometimes it's a team of identical atoms, like our H2 molecule, and sometimes it's a team of different atoms. The key is, if they're chemically bonded together, they make a molecule. Okay, but we've got to add one more little detail here, because it's super important. We need to know the difference between just any old molecule and a very specific type of molecule that we call a compound. And guess what? That reaction we just looked at has everything we need to figure this out. On one side, we start with a single magnesium atom, and on the other side, we end up with a hydrogen molecule, H2, and this new thing, magnesium chloride, or MgCl2. This table lays it all out for us. First, you've got the atom. That's our single unit, like magnesium. Then you've got the molecule, which is any group of two or more atoms, like our hydrogen, H2. And then there's the compound. See our example, magnesium chloride. Notice the key difference? It has to be made of different types of atoms. So here's the rule of thumb to remember. All compounds are molecules, but not all molecules are compounds. Our hydrogen molecule, H2, is definitely a molecule, but it is not a compound because it's only made of one element. Magnesium chloride, though, it's both a molecule and a compound because it's built from two different letters, Mg and Cl. Okay, let's zoom back out and put all these pieces together. What we've really been doing here is learning the basic language of all physical stuff, and it's a language that builds from super simple pieces into incredibly complex structures. It's really a simple progression when you think about it. You start with the letters, those are your atoms, then you bond them together to form words, which we call molecules. And when those words happen to use different kinds of letters, we call them compounds. That's it. That's the fundamental grammar of all chemistry. And I think this quote just sums it up perfectly. Atoms are the alphabet, molecules are the words, and everything you see around you, that's the incredible story being told with that language. So, I leave you with this final thought. If these really are the fundamental building blocks of our entire world, just imagine what we can build, what we can understand, now that we know the rules. And that's our look at the building blocks of everything. A huge thank you to Crush Concept Academy for the material that made this explainer possible. Thanks for tuning in.